Welcome to another deep dive, and this time we're heading straight into the world of exoplanets.
That's right, planets beyond our own solar system.
Exactly, and we're going to be exploring, what we currently know about these distant worlds
Yeah, L.
and how the search for them is really, I think, changing our understanding of the universe.
Right. I mean, it's such a fascinating field.
It is so fascinating.
And we have some awesome source material to dive into today.
Yeah, an article featuring insights from
Josh Wood.
Josh Wynn, a leading expert in exoplanet research.
Exactly. And, it's amazing how quickly this field is advancing.
Oh, yeah.
I mean, it wasn't that long ago that the idea of planets outside our solar system
Right.
was basically pure science fiction.
Yeah.
And now
Yeah.
we're discovering them by the thousands.
It's crazy how many we're finding. I mean,
That is.
first things first, how are we even finding these exoplanets? They're so incredibly far away
They are.
and basically invisible next to the glare of their stars.
Yeah. It's one of the biggest challenges in astronomy.
Yeah.
And to do that, scientists have come up with some really ingenious techniques.
Really interesting.
Yeah.
I've heard of the transit method, I think,
Mm-hmm.
where astronomers are basically looking for these tiny dips in starlight
Yes,
as a planet passes in front of its star,
exactly.
which is,
It's like trying to spot a flea crossing a spotlight from miles away.
oh, wow.
But, the sensitivity of our instruments has improved so dramatically
Yeah.
that this method has become really successful.
So that's how we're starting to analyze exoplanet atmospheres, right?
That's one way, yeah.
Like with the James Webb Space Telescope.
Exactly. When a planet transits in front of its star,
Uh-huh.
some of that starlight passes through the planet's atmosphere.
Right.
And by analyzing that light, we can actually detect what kinds of gases are present.
So we're literally sniffing the air of alien worlds.
Kind of.
Yeah.
Yeah, it's incredible what we can do now.
That's just wild.
Yeah.
What about that other method I've heard of, the Doppler effect?
Yeah, so the Doppler method, sometimes called the radial velocity method,
Right.
focuses on the star itself.
Go
A
ahead.
planet's gravity tugs on its star, causing a wobble,
Yeah.
ever so slightly.
Okay.
We can't see this wobble directly,
No.
but we can detect it by measuring shifts in the star's light spectrum.
Okay.
It's a bit like how the pitch of a siren changes as it moves towards or away from us.
Okay, I get it.
That's the Doppler effect.
Interesting.
Yeah.
So these subtle shifts in the star's light tell us there's a planet there,
Yeah, it tells us that there's an unseen planet pulling on it.
pulling on it.
Yes, and by analyzing those shifts,
Okay.
we can not only confirm a planet's existence,
Got it.
but we can also estimate its mass and how long it takes to orbit its star.
So we can figure out a lot about a planet
Yeah.
we can't even see.
A lot, yeah, just from those tiny wobbles.
Wow, that's pretty cool.
It is cool.
And these methods have revealed a whole universe of exoplanets that are, stranger than anything we ever imagined.
Oh, yeah, they're out there.
Right.
We're finding planets that are nothing like what we see in our solar system.
Really?
Gas giants orbiting closer to their stars than Mercury is to our sun.
Really?
Planets with highly elliptical orbits.
Oh, yeah.
Systems with multiple stars.
Yeah, I've heard about those.
It's challenging everything we thought we knew about planetary formation.
So it really is like opening a cosmic toy chest and finding all these crazy new planets
Exactly.
we never even knew existed.
Yeah, we had no idea.
One example I've heard about are these hot Jupiters.
Ah, yes, hot Jupiters.
Can you tell me about those?
These are giant gas planets that orbit their stars in mere days,
Oh, wow.
sometimes even hours.
Really so close to their stars.
They are so close.
Wouldn't they be scorchingly hot?
They are scorchingly hot,
Okay,
hence the name hot Jupiters.
right.
They can have surface temperatures of thousands of degrees Celsius,
Oh my gosh.
hot enough to melt rock.
That's insane.
It is pretty wild.
So our Jupiter's out there in the cold depths of our solar system,
Well-
taking years to orbit the sun. Why
Yes.
do these hot Jupiters even form so close to their stars?
That's a great question, and it's one of the big mysteries.
Yeah.
It's really forced scientists to rethink our models of planetary migration.
Oh, wow.
One idea is that these gas giants actually form further out,
Mhm.
and then they migrate inwards over time,
Right.
perhaps due to interactions with other planets
Okay.
or the protoplanetary disk.
Interesting.
Yeah,
So our solar system, with its neat and orderly arrangement of planets,
right.
might actually be the exception, not the rule.
That's what it's looking like.
Wow.
And if our solar system isn't the norm, then the possibilities for other planetary systems are truly mind-boggling.
It really makes you wonder if there are even more bizarre planets out there.
I think it's a guarantee that we
Uh-huh.
haven't even begun to imagine.
Right, and we haven't even talked about the rare Earth hypothesis.
Yeah, what about that?
So can you explain what that is?
Yeah, so the rare Earth hypothesis suggests that the conditions that allowed for complex life to arise here on Earth might be incredibly rare,
Ah,
perhaps even unique
um,
in the universe.
interesting.
It proposes that a whole series of improbable events had to occur
Yeah.
just right for us to exist, the
Right.
right kind of star, the right distance from that star, a large moon to stabilize our planet's rotation, and
Wow.
so on.
So we might just be incredibly lucky
I might be,
to
yeah.
be here at all.
It's one way to look at it.
It really puts things in perspective.
Yeah, it does.
But it also raises the question
Uh-huh.
of whether we should be focusing our search for life on planets that are exactly like Earth.
Right, because if life is out there, it might have evolved under completely different conditions.
Yeah, think about all those extremophiles we find here on Earth.
Yeah, that's right.
I mean, organisms are thriving in boiling hot springs,
Yeah?
freezing glaciers,
Uh-huh.
and even toxic waste dumps.
Yeah, it's amazing.
Life is amazingly adaptable.
It is.
So maybe we need to expand our definition of habitable.
Absolutely. I think focusing solely on Earth-like planets within the so-called habitable zone
Right.
might be too limiting.
Okay.
You know, Josh Wynn even argues that focusing solely on those zones might cause us to miss signs of life that look nothing like what we're used to.
Wow, that's such a good point.
Yeah.
We're so used to thinking about life as we know it.
Right.
But alien life could be completely different.
It could be based on a totally different chemistry,
Right.
thrive in different temperatures and pressures,
Yeah,
a completely different forms of energy consumption.
that's crazy.
Yeah.
I mean, we might not even recognize it as life.
Exactly. We need to be open to that possibility.
Yeah, that's both really exciting and a little bit daunting.
It is.
It makes the search for life even more challenging.
It does, but it also makes it all the more fascinating.
Yeah, it really does.
It does. We were talking about how alien life might be so different, we might not even recognize it as life.
It's pretty mind-blowing.
It is, and it's something that Josh Wynn talks about, how this whole field of exoplanet research often blurs the lines between science and science fiction.
Yeah, it's like those imaginative stories are inspiring real scientific discoveries.
Exactly. Early theories about exoplanets were often influenced by science fiction, and now the discoveries we're making are pushing the boundaries of what we thought was possible. It's almost like science fiction is catching up to reality.
That's so cool. So, okay, back to reality for a second. We've talked about how we find these exoplanets, but what are scientists actually doing to learn more about them?
Well, one of the most exciting areas of research right now is the analysis of exoplanet atmospheres.
You mean like we can actually figure out what the air is like on a planet that's light years away?
Yeah, believe it or not, we can. When a planet passes in front of its star,
The transit method?
exactly,
Right.
some of that starlight filters through the planet's atmosphere. And by analyzing that filtered light using a technique called spectroscopy, scientists can actually detect the presence of different molecules.
So we're looking for specific chemicals that might indicate the presence of life.
That's a big part of it, yeah.
Right.
We're looking for what we call biosignatures,
Okay.
gases that are likely to be produced by living organisms.
Like oxygen,
Ah.
right? That's what we breathe. So finding oxygen in an exoplanet's atmosphere would be a pretty big deal.
It would be exciting for sure, but it's not quite that simple. While oxygen is essential for life as we know it, it can also be produced by non-biological processes, so we need to be careful about jumping to conclusions.
Okay, so what other biosignatures are scientists looking for?
Well, methane is another one that gets scientists excited. It can be a byproduct of biological processes like digestion of food by certain microorganisms.
Oh, wow.
But again, it can also be produced by geological activity, so it's not a slam dunk indicator of life on its own.
So we need to look for a combination of different gases, right? Like if we found both oxygen and methane in an exoplanet's atmosphere, that would be a stronger indication of life than finding just one or the other.
Exactly. We need to consider the context, the overall composition of the atmosphere and the planet's environment. It's like putting together a puzzle. Each piece of evidence helps us build a more complete picture.
That makes sense. It sounds like a really complex process.
It is. It's cutting-edge science.
What stands out to you about this research?
What fascinates me is the sheer scale of what we're dealing with. We're
Yeah.
talking about analyzing the air of a planet that's trillions of miles away. It's mind-boggling.
It really is.
Mm.
And we're not just looking at individual planets, right? We're
Mm.
discovering whole planetary systems with multiple stars and all sorts of strange and wonderful planets.
You got it. Every new discovery adds to this incredible diversity of exoplanets that we're finding. It's challenging everything we thought we knew about planetary formation and evolution.
It's like our own solar system is starting to look pretty ordinary.
Right. Remember those hot Jupiters?
Yeah.
The fact that gas giants can exist so close to their stars has really thrown a wrench into our traditional models of planet formation.
So exoplanet research isn't just about finding alien life, it's also about understanding our own cosmic backyard better.
Exactly. By studying these distant worlds, we're gaining a deeper understanding of how planetary systems form and evolve, including our own. It's like getting a glimpse into different possible timelines for our solar system.
That's fascinating.
Yeah.
Okay, so we're learning a lot about exoplanets, but there's still so much we don't know, right?
hmm
What are some of the big unanswered questions that scientists are grappling with?
Well, one of the biggest mysteries is how planetary systems form in the first place. We have some good models, but there are still a lot of details we're trying to figure out. Like, how do those protoplanetary disks, those swirling clouds of gas and dust around young stars, actually give rise to planets?
So we don't even fully understand how planets are born.
Not entirely. And then there's the question of habitability. We talked about expanding our definition of habitable, but we still don't know how common habitable planets are.
Right, that's the big question. Are we alone in the universe?
It is. We're getting closer to answering that question with every new discovery, but for now it remains one of the most profound mysteries in science. And that mystery is driving a lot of the technological innovation in this field.
I was just thinking about that. All this research is pushing us to develop incredible new telescopes and instruments, right?
Absolutely. The telescopes we're building now are orders of magnitude more powerful than anything we had just a few decades ago.
Like the James Webb Space Telescope.
Exactly. It's already revolutionizing our understanding of exoplanets. And we're just getting started. There are even more ambitious projects in the works.
Even more powerful telescopes. Tell me more.
Well, there's the Roman Space Telescope, which is set to launch in the next few years. It's going to be amazing for surveying vast areas of the sky, looking for exoplanets, and studying dark energy.
Wow. And what about directly imaging exoplanets? I know that's a huge challenge because planets are so faint compared to their stars.
It is a huge challenge, but it's one that scientists are determined to overcome. That's where the Habitable Worlds Observatory comes in.
I've heard of that. It's still in the early stages of development, right?
It is, but it has the potential to be a game changer. It's being designed specifically to image Earth-like planets around nearby stars.
So we could actually see these planets. Not just detect them indirectly, but actually see them.
That's the goal. We could study their atmospheres in detail, look for signs of oceans, continents, maybe even clouds.
That's incredible.
Yeah.
It would be like looking at another Earth.
It would be a monumental achievement, and it would open up a whole new chapter in our exploration of the cosmos.
I can't wait to see what the future holds for exoplanet research.
Yeah.
It feels like we're on the verge of some truly groundbreaking discoveries.
We are indeed. And who knows, maybe one day we'll even find definitive proof that we're not alone in the universe.
Welcome back to the Deep Dive. We've been exploring this incredible world of exoplanets. You know, these distant worlds orbiting other stars.
Yeah, it's been a wild ride so far.
And it makes you think, doesn't it?
Yeah, for sure.
We've found planets with 2 suns, planets that rain molten iron,
Wow.
planets that might have oceans of liquid diamond.
It's crazy.
It's hard to even wrap your head around all these things.
It really challenges our definition of what a planet can be.
Yeah.
And as we uncover more and more of these strange new worlds, it makes you wonder, what does it all mean?
That's what I was thinking about. You know,
Yeah.
we've talked about the science and the technology and the search for life, but now I kind of want to get philosophical.
Okay, yeah.
Like, what are the implications of all these discoveries? How does it change our perspective
Yeah.
on our place in the universe?
That is the fascinating part, you know. For centuries, humanity has wondered if we're alone in the cosmos. And now, with every new exoplanet we find, that question becomes more and more pressing.
You know, when I was a kid, I was obsessed with science fiction.
Really?
All those books, alien civilizations and interstellar travel.
Yeah.
And it all seems so fantastical,
Right.
so far-fetched. But now with all these discoveries, it feels like science is catching up to those fictional worlds.
It's true, the lines are getting blurred, and as we learn more about the sheer diversity of exoplanets, the possibility of life beyond Earth becomes more and more plausible.
But like, what if we never find that definitive proof? You know, what if we search and come up empty?
That's a good question. But even if we never find another living being out there, the sheer fact that these planets exist,
Right.
that they're out there in such staggering numbers
Yeah.
and with such incredible variety, I think has already fundamentally changed our understanding of the universe.
Yeah, it used to be that our solar system was all we knew,
Mm-hmm.
and we thought it was like the blueprint
The standard model.
for other planetary systems.
Yeah,
But now we see that it's just one tiny example,
exactly.
maybe not even a typical one.
Yeah, it really puts things in perspective.
It's humbling, isn't it?
It is.
To realize that our little corner of the galaxy is just one of countless possibilities.
One of many, and it just opens up so many questions. How many of these planets are habitable? How many might harbor life, even if it's different from anything we can imagine?
And what about intelligent life? Could there be civilizations out there that are far more advanced than our own?
That's a mind-blowing thought, and one that's hard to dismiss when you consider the vastness of the universe and the sheer number of stars and planets out there.
Yeah, it's almost too much to comprehend. Billions upon billions of stars,
That's incredible.
each potentially with its own planetary system.
Yeah.
It makes you feel so small.
It does, but also incredibly connected. We're made of the same stuff as those stars and planets. We're part of this grand cosmic web, and that's a pretty awe-inspiring thought.
Even if we never find another intelligent civilization, I think the search itself is worthwhile. It's pushing us to develop new technologies, to expand our knowledge of the universe,
Right.
and to contemplate some of the most profound questions about our existence.
It really speaks to our curiosity, our drive to explore, our desire to understand our place in the grand scheme of things.
So as we wrap up this deep dive into the world of exoplanets, here's a final thought to ponder. Even if we are alone in the universe, does knowing about the existence of these other worlds change how you view our own planet? Does it make you appreciate the fragility of life, the preciousness of our own little blue marble?
It definitely makes you think.
Yeah.
That's for sure.
That's it for this deep dive. We've covered a lot of ground, but there's always more to explore. We encourage you to keep learning, keep asking questions, and keep looking up at the stars with a sense of wonder. Who knows what amazing discoveries await us out there in the vast expanse of the cosmos? Thanks for joining us, After All.